Yeah, the stickies help force everyone to be on the same page.
I'm here.
Yeah, just a second. All right, does everyone who wants to participate have stickies? I assume yes. Put up a green, no. All right, so put up a green sticky if you've got Conda and everything downloaded locally. Red if you're hoping that this is going to work off Jupyter Hub. So put up a green sticky if you've got Conda downloaded and installed on your machine, and as far as you know, it's all set up correctly. All right, cool. And so the way this works is if you don't put up a sticky, I'm going to ignore you. So if you want to participate, participate. Otherwise, I'm going to assume that you're not and not try to help you. So first thing we're going to do is clone the repo for this little tutorial. I slacked out the link. So you guys will do git clone. For me, it already exists. Everyone else, grab that repo, cd to it. So yeah, I slacked it out in general. All right, cd to that directory and start up a notebook. And so everyone who's not there, put up a red sticky, green stickies if you're there. All right, so, right. So did you were able to clone the repo? So cd, yeah, for the sake of argument, cd into the repo directory. And then just Jupyter Notebook. Can you guys see that back there, or should I make it bigger?
A little bit bigger.
Yeah, so start up a notebook like that. All right. Did you get the repo?
Oh, sorry.
What's up?
Oh, sorry.
Oh, you're good? Okay. All right, so show of hands, how many people here are familiar with Jupyter? Okay, so I'll move through the first part of this pretty quick. Go ahead and open up the Neurohackweek Ipython notebook after you've started your notebook server. All right, so just gonna go.
Gives me notebook validation.
Yeah.
But what does that mean?
I don't know. Some conflict between the version that I built this in and the version that you're running, and hopefully that won't come up again. All right, so everyone can take your stickies down now. We're just gonna go through some of the basic functionality. So notebook navigation. So the notebook's laid out in a series of cells. you'll notice that the cell you've got highlighted has this colored bar over on the side. When that's blue, you're in command mode, and you can use the command mode shortcodes to manipulate and navigate cells. If you press enter on a selected cell, this turns green, and then you're in edit mode. And so you'll see you get a cursor inside the cell, and you can edit the contents of that cell. Once you've got the cell the way you want it, you can press Control Enter to run it in place, or Shift Enter to run that cell and move to the next one. The Help menu has links to documentation for notebooks, extensions if you've got them installed, and a whole bunch of really commonly used Python libraries, as well as this nice huge list of keyboard shortcuts. So like I said, there's some shortcuts for command mode and a different set of shortcuts for edit mode. Default, the notebook will display the value of variables or statements that are alone on a line. So foo here. Sure. We didn't tell Python to print foo, it's alone on a line by itself, so it goes ahead and dumps that out to the output. And this can be really nice when you're looking at big tables and pandas. It'll automatically format your tables all pretty. So this is loading a pandas data frame from the Seaborn preloaded data sets. Yeah?
I just remediated it just in case. That fancy time thing on the bottom of each cell, is that an extension?
Yeah, so these are, so I'm running extensions. You can see if you're running extensions if you go to your, go back to the Home tab, and if you've got extensions running, it'll be a tab like that. So if you guys haven't installed them, then you won't have some of the fancier stuff.
If we haven't installed extensions, if we haven't installed them, are we lower how to do that today?
There's a link in here for installing it.
Okay.
It's just a conda install. Yeah. So this is a really nice feature if you want to just get a quick look at what some variable is. The vast majority of the time, if I've got some big table of data that I want to look at, I'll dump it to the console this way instead of like opening up a CSV in Excel. There are times though when you have multiple variables in a cell you want to see the status or the value of, and so you can actually import from Ipython core, interactive shell, and change the this parameter, the setting here, to all, and then all the statements that are alone on a line will get printed out instead of just the last one, which is kind of nice. It's one of the reasons I really love notebooks is that it's super easy to get help for the functions you're using. So if you put your cursor inside the parentheses of a function call and do Shift Tab, it pops up the short version of the doc string. You can expand it with that caret, and then you've got the doc string. It's really nice. You can also pull up the documentation with question mark before or after the name of a function, library, method, variable. So if there's a doc string for it, that'll bring it up. You can also execute shell commands inside your notebook just by prepending it with the exclamation point. So hashtag or exclamation point pwd tells you what directory in. You can list it. You can do any shell command you'd like in there, and I'm pretty sure it's going to just go to whatever your default shell is set for your profile. If for some reason you've got a T shell set as your default, I'm very sorry.
But that limits us to call some process, right?
Yeah.
If I call test command using the subprocess.call, it doesn't allow me to call basically shell command in Jupyter mode.
I'm not sure I follow.
So if I have to run some command on shell,
Yeah.
and through a Python command, then I will do subcall,
Yeah.
process subcall, right?
Right.
But it doesn't work in Jupyter.
Subprocess works from Jupyter, yeah.
I tried it. Well, we can talk.
Okay, we can talk later. I've used subprocess. I usually use subprocess.checkoutput, and it works for me. And the other nice thing is that this is automatically turns into a subprocess call when you save it to a Python script. So you can do file, download as Python, and that file gets, in that file, this gets changed to a subprocess command. So some features that I just found out about when I was preparing to talk to you guys about this are multi-cursor and alt select. So if you want to drop a cursor on multiple lines, you can just hold command while you're clicking, and every place you click, you'll drop a new cursor, and then you can edit all those lines simultaneously, which is kind of neat. You can also hold Alt and select to select a box, as opposed to selecting by line the way you normally would. You can also do that to just drop your multi-cursor. So I was going to have you guys do a quick little exercise and do what I just showed you how to do, but the exercise notebook extension is a little bit broken right now. So notebook extensions, you can find the guide for installing them there. It should be as easy as conda install. So we can give that a shot. So if you're in command mode,
It can't run if you have Jupyter running. That's the issue. You can't install extensions if it's already running.
even if you reset the notebook, or if you reset the server?
Yeah, it's only like, you cannot configure while Jupyter.
Ah, well, that's easy enough.
I killed it. And
Yeah, so go back to your console, kill your notebook server, and paste in this conda install line. I'll put that on the Slack. For this class, I'm just going to keep responding and have a thread going under that initial post about the repo. Or I'm going to try and fail miserably. Anyway, it's in general. So throw up a red sticky if you can't get those extensions installed. And I guess a green sticky once you've got them and got your notebook back up and running. Nope. All right, so now everybody should see notebook extensions when they get their notebook back up and running. So green stickies once you can see that.
I like the sticky idea. What did you?
I think Adam and John, who I work with, stole it from a software carpentry class. But yeah, it's a great idea. So everyone else is still downloading and installing? All right. I'm sorry. Sorry, poor Wi-Fi. while that's installing, I'm going to go through and talk about some of the Ipython magics. But throw up that green sticky once you get those extensions installed. So if you're running with a Python kernel, an Ipython kernel, there's some special built-in functionality that you can access with what are called magic functions. So there are line magics that start with a single % and only affect the line that they're called on. There's cell magics preceded by 2% signs that you place at the beginning of a cell, and it modifies the behavior of that entire cell. There are a whole bunch of magics, but here are a couple of handy ones. If you need to modify environment variables, you can use the env magic. So running that will dump out all of the environment variables you've currently got defined. Then you can say you want to set a new environmental variable foo to the value warming up. You can do that inline in your notebook and check the value of that once you've got it set. You can also just treat that like a normal function call and assign it to a variable. So you can also use the OS library to pull down environmental variables, but this is a nice little shortcut for doing it if you're inside a notebook. There's also a bunch of magic functions that allow you to manipulate files. So if you just have the magic load boring.py, which is a file in that repo, execute it, and it loads the contents of the file and turns your load magic into a comment. Everyone who doesn't have the notebook extensions installed yet, is it still cooking, or have you just given up on it?
Mine failed for server running, but I don't have it running.
Are you sure you don't have it running somewhere?
I've been looking, and I really don't think I do. I quit all my terminals, so I don't know how it...
Huh.
So I'm not super clear what's happening with that one.
Yeah.
I did another one running, but I didn't know what else with that.
I thought that was it, but I don't have a Jupyter running.
Can I, in the meanwhile, comment about load?
Yeah.
One cool thing you can do with load is actually load a URL. If the file is somewhere in the URL online, you write load and you load that file from that URL. So it doesn't have to be locally on your machine.
So it's smart enough to go.
It does the request, it takes the file and pastes it in your notebook.
So if you wanted to load it from the repo instead of the directory, you should be able to just do that.
Wait, I tried.
Oh, that one actually.
That loads the
The
HTML.
entire page.
Yeah.
You got the entire page.
Yeah.
But you need the raw, yeah. The raw, if you went to the raw link for that.
Yeah.
The nice thing is a lot of projects have examples that are Python files. You can get the URL for those things and get them in there as like scikit-learn examples, things of that sort.
Yeah.
I tried. I don't think I should have, but I tried to open the Jupyter
So it'll be like raw.github.com.
thing.
Yeah.
To find the kernel, and then I just still fill this in. So yeah, I'm just sort of confused about what it's. What is it?
All right.
So it's to install the extensions. I'm going to.
Yeah. So there's an example of loading it from the HTML. You can also write files with a cell magic. This is arguably less necessary now that you can open up. There's actually a text editor in here, so if you've got a text file, you can open up and edit it in your Jupyter notebook session. But sometimes it is still nice to have that inline in a single notebook. So you can write out a file, and then with the run magic, you can run that file. And in this case, we're defining the variable bar. So bar equals OAuth environment foo. You run it. It gets defined in your environment, and you can print it. So that can be really handy. You can also run Ipython notebooks that way. So if you're working on if you're developing your analysis pipeline, you defined a whole bunch of functions and tested them in one notebook, and then just for the sake of your insanity, you want to like actually do some more analysis that uses those same functions in a different notebook, you can just run your original notebook and it'll load all those functions that you've defined there into your current notebook. So it's kind of like a first little baby step on the way to defining all those functions as part of a library without having to go down that whole path. The other useful magics are for debugging. So you can turn on automatic Python debugger. So that's whenever something breaks, it's going to drop automatically in the Python debugger. So that's great if you've defined some function that may or may not have issues in it. Turn on the automatic debugger, and when you run that function, you get dropped right into the Python debugger. You can see where you are. So LL will list the code around the break. There are a whole bunch of functions, a whole bunch of functionality built into the Python debugger that you can read more about there. So we can turn that back off. So one thing really important and very common, at least snafu for me, is to forget that you've got a debugger running somewhere. And so you go and you run another cell, and you're like, why in the world is that cell taking so long? It's because this cell that you've got your debugger in is still running until you type Q to quit it. And any other cell you run is going to look for all the world like it's actually running when it's really just waiting for you to finish your debug. So we'll turn that back off.
You can also press the stop button.
Yeah, you can also interrupt it. And then if you've run a function and you didn't have the foresight to turn on the automatic debugger and you're like, what the hell happened? Why'd that break? After the fact, you can do post-mortem, just the debug magic, and that'll drop you back in to the last error that was thrown in that notebook. And so this is how I usually end up debugging things. So you guys notice that I've got an extension running that's timing every execution. There are also magics that let you time the execution of a cell, time it, runs the statement 100,000 times, and gives you the total execution time, repeats this by default 3 times, and returns the quickest result, which is going to give you an idea of the best case for execution of your code on your machine. Using the mean isn't necessarily accurate, because the slower execution times are usually going to be caused by other processes interfering with Python and have less to do with the actual intrinsic properties of running the code that you were running. So taking the quickest of those 3 sets of 100,000 is gives you the best idea of what is the quickest execution for that code on your machine. And then prun allows you to do profiling. So it runs the statement you give it and returns the number of times each internal function was called within that statement. So got a couple of functions defined here. Got a slow reverse function that's iterating through a list and inserting the last element into the front. Inserting into lists is slow because in Python is slow because it has to update the index of every subsequent item in that list. So that's a really slow operation. The faster way to reverse a list is to just use this slice notation, which says count in step size of -1, which is kind of Python shorthand for reverse the list. So we can use time it to compare those 2 executions and see what the difference in performance is. It's going to take a little bit because, like I said, it's running each of those 300,000 times. And you can see doing it the slow way is about many, many times slower than doing it the fast way. And then if you want to profile and see what function calls each of those 2 ways of doing it is actually doing, you can use the prun magic. And here I'm actually setting the results of the prun to a variable, and then you can get at the properties of that profiling run. So dump stats, a whole bunch of different methods available for those profiling objects. So the folks who were installing notebook extensions, I know he's got problems. Is everyone else okay? Cool. So I'm going to go over and talk about the notebook extensions real quick. So again, these are experimental, not guaranteed to work everywhere. You can disable the ones that they think are likely to break, but that turns off most of the really neat ones. So it's more fun to run with some of the stuff, even though it might break. So auto pep8 does automatic pep8 or style enforcement in your notebook. So it's an auto linter for the notebook code, which is really handy. Exercise should allow you to create little hidden cells with the answers to exercises. It's being a little bit buggy right now. Table of contents is really great for organizing your code, especially if you're going to be handing the notebook off to someone else. It takes all the headings and creates this nice table of contents that lets you jump around to the different cells. And so in our lab we use it a lot, and it's super handy for getting a quick overview of, okay, what is everything this person did? I'm curious about how they did that. I can go there real quickly in the table of contents rather than having to scroll through. Sometimes these notebooks can get incredibly long with all the figures being dumped out and everything like that. So, speaking of pictures, you can use the matplotlib inline magic to turn on inline graphing. So we're going to import matplotlib, numpy, and pandas, and we need the pyplot package from matplotlib. So matplotlib inline, and then we're just going to use that iris data set that we got earlier, and we reset between now and then, so we're going to need to go back and get that again. And it happily drops your figure right there in the notebook, so the analysis code, your markdown describing what you did, and the figures that you produce are all in the same place. So this clearly can help check off a lot of those goals of reproducibility, where you have all of the code for all of your figures, because if you make all your figures in matplotlib in a Jupyter notebook, like they're defined in the place with the code for the analysis that generated them. And I can't ever talk about plotting in Python without plugging Seaborn. Matplotlib is fine, but it's kind of ugly. Seaborn automatically, though it is getting better, it's better than it used to be. Seaborn, if you use this seaborn.set, automatically creates some nice styling for your plots. And it also has a whole bunch of functions that make plots much easier. Things that would be otherwise quite complicated. So one of my favorites when I'm trying to see what relationships possibly exist in a data set is the pair plot. So this is each variable, a scatter plot of each variable with every other variable, along with histograms on the diagonal. And you can go in and mess with some of the settings and get different plots in the upper and lower diagonals if you want. There are a lot of neat built-ins like violin plots in Seaborn, and I'm sure other folks will talk about this later, but Seaborn is great if you're plotting in Python. So Anisha was talking to you guys about interactive widgets interactive plots with D3. Ipython widgets are Python objects that are represented in the browser. So again, this is kind of like D3. You've got the browser being aware of your data elements that you can use to create interactive GUIs. They're particularly useful for exploring your data and there are really low-level interfaces to create these interactive widgets that we're not going to get into today. We're just going to we're going to use the interact and the interactive methods, which they're not officially magics, but they're pretty great functions that take what you've passed it and guess what kind of widget you're trying to make. So we'll see how they work in a little bit. So interact creates these UI elements so that you control the input parameters to a function. So first we'll need a function. First we'll need to import all this stuff. Does this work for you guys, or do we need to install widgets? So if you guys are following along, try to run this interact import. Does that work? Cool. All right, so we'll define our function. This is just going to be print x because I want to show you a whole lot of the different types of variables you can pass and what the result is. So if you pass it a float, you get a float slider. If you pass it an int, you get an integer slider. Bools get checkboxes. Strings generate text areas. Lists and dictionaries both generate dropdowns. The difference is with a dictionary you can define the value that's displayed and the value that's saved for that variable differently. So in this case you can see option 1 gets shown as option 1, but the actual value of x is 1. And so that can be handy sometimes. If you want to use a dictionary there, and you care about the order that the items appear in your list, you might need to use an ordered dict, because by default Python dictionaries don't have any order. So you'll define this nice dictionary, spin it a bunch of times saying, oh, I want everything in this particular order. And then if it's not an ordered dict, Python's going to ignore whatever order you defined, and then your list will be all out of order. So these examples are fine. They don't do much. And we've seen that Jupyter can do inline plotting. So now we're going to make an inline interactive plot. So this is our function that's just going to draw a little plot of x to the a, where a is a variable and x is lin space, so just values between 1 and 10, 100 values between 1 and 10. And so if we interact that function with very, very little work, we've got a nice interactive figure inline in our Jupyter notebook.
I have a question.
Yeah.
When I do that, it creates a new plot. It makes a list of the plots. So if I scroll it, I now have 15.
Okay.
Is that
That is an issue that I've seen before. Off the top of my head, I can't remember how to fix it, but we can talk afterwards.
I have the same issue.
Okay. Does anyone have it actually working? Okay, so it does work for some people. So we'll try to figure out afterwards what's causing that behavior. So this is great, but interactive is doing a whole lot behind the scenes. Whenever you run this, it's creating a widget object, and if you run interact, it doesn't return that widget object to you. So whatever methods or properties exist for that widget, you lose them. You can't get access to them anymore. And so instead, you can use the interactive function. And that, instead of automatically creating the widget and displaying it, just returns the widget object. So here you can see if we run interactive with our same plot function, give it a value for the parameter of 2, we get this widget object back. And you can see the type of it. It's Ipython widgets interaction interactive. And then with the display function, you can display that widget. You can also if you just execute the widget alone in a notebook cell, it'll also create it. So one thing you might notice is that these are the same widget object, and I've displayed them from 2 different cells, but it's the same widget object, just displayed multiple times. So they're the same object. So if you change one of them, you can see it's automatically updating the other as well. So that's kind of a little bit of a peek into how it's actually working under the hood. There's a widget object that's abstracted away from the HTML. You can interact with it through the HTML, but those changes get passed back to the widget object, and then any other displays of that widget object also update. So you could use that to create linked plots and things like that. But now that we've got the widget object, we can also check the keyword arguments of that object, and it'll show us what the value of the parameter is. So if you want to do some by hand exploration of your data, and you settle on, oh, I think this value, well, that value is boring. I think that value of that parameter looks best. I want to be able to save that out programmatically. You can just grab that from the keyword arguments.quargs. So I'm going to have a little exercise for you guys now. So hopefully this is working, and we can maybe take this time to figure out what's going on with you guys. For everyone else, I want you to make a function. So I've created this function for you that's going to plot a trigonometric function. It takes 3 parameters, frequency, amplitude, and a string for the function name. Create a widget that allows those 3 input parameters to be manipulated interactively. And you may or may not end up needing to debug this trig plot function because I literally just wrote it. So go ahead and try that, and I'm going to try to help these guys. So everyone take your stickies down, put up a green sticky once you've got that. All right. So what's up?
Okay. So you have to explicitly say plot.show.
Did you run the matplotlib inline?
I think I ran everything. So if I take this plot.show is what the help suggested. So if I do this, then we get a lot of these.
Yeah. Yeah.
So it was run. Then if you go down to here,
Okay.
we get that. But if you do plot.show,
Cool.
then it works.
All right. So if you're having the issue where messing with the interactive slider ends up dumping a whole bunch of plots instead of just updating one, follow the last plot call with plt.show, S-H-O-W, open close parentheses, and that will actually force it to update smoothly. Yeah.
I'm not able to get the widget.
Hey, here, did you run?
Yeah.
Do you start this notebook from the navigator here?
No.
Okay.
This I didn't start from here either. I started from iTerminal. This one.
So did you try doing Anaconda logout?
I didn't do that. it's going. So after that I have to shut down the kernel and start again?
Yeah. For this actually, yeah, you might need to. This might complain that that's running actually.
Just go.
Yeah. Oh, so yeah, I killed it there.
Okay.
All right. So once that finishes, see if you can.
So now I should fire up the Jupyter notebook from terminal.
Yeah, and you'll need to run down all the way back through to widgets.
Run all and then see.
Yeah.
Thank you.
Yeah. Right. So has anybody figured out the bug in trig plot? Is there a bug in trig plot?
Yeah, the name for the apex name, they have an extra space.
Right. So if you get rid of those spaces.
And you need also the actual parameters to compute the name. So md.course amplitude and frequency of context.
Yeah, I mean, are you saying I need to make more changes to this?
Yeah. No, okay, the apex. So you only need the name of the.
So this function should be fine now. So if you get rid of those spaces, that should be fine.
Yes.
So just to create a bug in here for you guys to track down, there were extra spaces there. So it was coming in, and if you had the default function name sign, it was come in here and say, oh, that's not equal to any of those, else not implemented error.
That makes sense.
Yeah. And spaces on variable names, it can be super hard to diagnose because you print stuff out and it doesn't appear that there's anything there, especially you're loading stuff from CSVs. It happens so often. All right. If you guys have got your nice interactive figure, can you put up a green sticky? Or if you're stuck, does anybody have questions?
Supposed to output like an array.
Yeah.
It is.
Yeah, so if you look, the end of this is returning y.
Okay.
And y is just the result of your calculation. And so if you've got the interactive function working, go ahead and do the next part too. So assign the results of the interactive plot to a couple of variables, tpres and tpargs. And if you've got it figured out and you're sitting next to someone who hasn't, maybe give them a hand. So you guys, how you guys doing?
I got lost like halfway through because something wasn't working.
Oh, you had that.
Yeah, I have this working.
Okay, so this bug you can get rid of, where it's showing all those plots. You just need to put in a plt.show in the function. So up here.
So that just like tells it to update what it's showing instead of printing.
Yeah.
Okay, cool.
then for this, yeah, you've got the function. You just need to write the wrapper call that's going to give you an interactive plot for that.
Okay.
So I run it, but I don't know how I get this array. It's because of the return, right?
Yeah.
So I should delete it or what?
No, you can leave the return. Maybe you just need to drop that plt.show in there.
Ah, okay.
See if that helps.
Great.
Yeah.
Thank you.
Yeah, perfect. And yeah, so if you use interactive instead of interact, you can actually get the values of those.
I was doing it, but
Yeah.
there was this error. So.
Right.
Install it says that the Jupyter notebook is running, but not
Yeah.
it is running.
Do a top.
What? I've got Jupyter notebooks running somewhere, but not this. Which server are you talking about?
Yeah, I mean, were you able to? Was Anisha able to help you fix the error you had?
Yes, there was a hidden notebook running that I don't really understand how it was running, but it was.
So we basically just found the function that runs that check and ran it and found the PID.
PID.
And pulled it.
Okay.
It's not clear how it was. It's something that I did. It must have been days ago.
Okay. So yeah, maybe Anisha can help you find the PID for that and kill it.
Oh, I can do that.
Yeah.
So,
You can do that.
so,
kind of.
Sort of.
so I do have some Jupyter notebook running, but this is a fresh install. I make a new environment. I made a
Kill all link that.
Yeah. So the extension has to modify the Jupyter config, which is global. It's not in an environment.
Oh shit! So that's annoying because if I want to not run the extension, then I have to uninstall globally.
Yeah. It's not ideal. The extensions are really nice though. Why would you ever want to run without them?
Okay, that's messy.
Yeah, it is messy. It is.
Oh shit!
Yeah.
That's bad.
All right, so if you're really truly absolutely stuck, you can go back and look at the files, and you can open up this other notebook, Ipython notebook solution, and the solution for this is in there. So should end up with something that looks like that. Oh. So interact takes what you've given it, figures out what kind of widget you want it to create, creates that widget and displays it. It doesn't return the widget object. So if you say some variable equals interact, the result of that variable is going to be none. So interact doesn't return anything. Interactive, on the other hand, just creates the widget. It doesn't automatically display it, and it returns the widget object to you. So if you want to get some information about that widget that you just created, you need to use interactive. Interact is, I mean, it's easier. You don't have to deal with this object, but it's more limited. And a couple people found that we need to put this plt.show in there to get the plot to display correctly. But yeah, so you should have something that looks like this. And then again, since it's interactive, you can actually get the results and the args from it. Right, so I got 5 minutes left. I'm going to run through real quickly and show you guys some of the other widget options and some other neat things you can do with Jupyter notebooks. So you can run that if you're brave. It may or may not work. But once you've got widgets, you can actually have these interactive Python widget-driven plots for your nifty images right in line in your notebook, which can be really handy. So this is using scikit-learn and sorry, the name of the other packages is going to be nylearn to render the nifty images in line. And since it's widgets and it's interactive, you can slice through and the visualizations down there update. You can also, nylearn has a bunch of built-in plotting functions. And you can run those with interact, or you can run those with the widgets and get a nice glass brain with a definable threshold for your stat maps. Having the slider like that means it's trying to update for every value, so it can get a little bit slow. There are things you can do where you actually have a button to press to make it update only after you've modified all the settings you want. And then so moving beyond interactive plotting, there are a whole bunch of different kernels that you can get for your Jupyter notebooks. Jupyter is explicitly not only for Python. It actually refers to Julia, Python, and R, which are the 3 kernels it was designed for. Julia is a newer language. The goal with Julia is that it is a higher level language. It's easier to code, but it's also very fast. So it's compiled on the fly and has performance. They claim they've got a lot of benchmarks showing that you can write stuff in Julia and get performance similar to C with very little optimization. You don't have to do any optimization or anything on the Julia side. But it is a whole other language to learn, so there's the trade-off. But you can run a Julia kernel. I'm not going to go through showing you how to install that right now, but the instructions are in there and in some of the links. But once you've got that installed, you can just create a new Julia notebook or open up this Julia example. And yes, your PEP 8 will choke because PEP 8 does not apply to Julia. But you can load in your plots package and then run plots just right in line. The first time you run it tends to be a little bit slow because it'll compile it, but second time it runs, it's super fast. So can be a really nice language for some tasks if Python is just really slowing you down. You can also get R kernel, and so you can go, once you have that installed, you can go up here and start an R notebook. Oh yeah, you can see here it's finished. So it's got fairly attractive plots by default you can interact with and all sorts of stuff. R, so you can install R kernel. You can also install RPy2, which is a wrapper for R that lets Python and R communicate with each other. So then you can do fun things like have R magics. So on a single line, you can run some R code, or you can have a whole R cell and pass an input from your Python notebook. So you can do a bunch of processing. String processing especially is much easier in Python than it is in R, at least in my experience. And then once you've got your data frame all nice, if you're someone who just absolutely loves ggplot and thinks matplotlib and seaborn are the worst, you can use rpy2 and pass your data frame into R and do your ggplot right in the same notebook. So you don't even need to go open up a R kernel notebook. And then this last bit down here is here for you guys if you'd like to use it. It's may or may not break things. This is software is under no guarantees. But if you're using Ipython notebooks with Git, having all of the figures in line can end up being kind of a pain in the butt, because every time you update those cells, because the data for the figures is actually encoded in the notebook itself, so it's got these huge binary blobs inside it. And so looking through the diffs in GitHub for an Ipython notebook can be kind of a nightmare. There's like thousands of lines changed. So instead, you can, what this little block is going to do is write a section to your Jupyter notebook config that automatically saves the script, so the .py, and the HTML every time you save your notebook. And so if you track all the three of those things with Git, then the diffs in the .py you can review to see how the code was changed. And the diffs in the HTML will tell you about code changes as well as output changes. And then if you've checked both of those, you can feel reasonably secure in accepting the changes to your Ipython notebook file without having to go through and painstakingly look through the really horrible diff output for the Ipython notebook. So if you want, you can drop this in your Jupyter config file, and you'll get that nice functionality. But again, it may break things. You'll be tracking more files in your GitHub. And you might at some point forget it's there, and then in 6 months be like, why do I have all of these extra files? At your own risk, but I'm totally happy to help anybody out with that if they want to do it. And yeah, that's my time plus a little bit. Any questions? Great. If you do have questions, find me on Slack.